All production-ready applications should have good form validation in place to ensure end users provide proper and complete data. Let's use the validation library VeeValidate to help us quickly provide this for our form. The first thing we should do is install it. We can do that with npm. I'll type npm install VeeValidate and specify the version that I'd like, in this case 4. Now, let's use it to add validation to the registration form. There are two primary components we need to import and use from the VeeValidate package. They are the form and the field components. Next, I'll register them with the components property, providing alternate component names to fit in with the rules from the Vue style guide. That is, we want our component names to consist of 2 words. This allows us to replace the form element with the vForm component. The difference is that now the form submit event won't fire until the form has passed validation. Also, we no longer need to add .prevent to the submit event, as VeeValidate already assumes we want to handle the form submission ourselves, instead of letting the browser handle it in the default manner. Likewise, let's also change out all our inputs for vFields. I'll start with the name input. It's also important that we provide the name prop, as this is how VeeValidate knows how to identify the field. I'll call it name to match the input ID and the vModel. We'll do the same for username and email, password, and lastly, the avatar. We also need to update our closing form tag. Great! With those in place, we can start adding validations. VeeValidate gives us 2 different options on how to do this. Let's look at the first one in this lesson. The first option is to provide all the rules at the form level with the validation schema prop. It takes an object whose keys are the names of the fields we'd like to validate, and values are a function that we want to run in order to validate the field. Let's pretend for now that validating username and name is enough. As you might expect, each of these functions receives the value of its corresponding form field. We can use that value to make sure that what the user types in is in fact a valid value. Let's say that we want the name field to be required. To do that, we'd check if the value was truthy. And just to account for empty spaces, we'll also check that it's truthy after it's been trimmed. And if it passes, then we can return true, meaning the field is valid. However, if the field is not valid, we want to return a message saying why it's not valid. Sweet, that should do it. For now, we can also copy and paste the function to make the username required too. Let's check it out in the browser and see where that gets us. You'll see that if I submit the form with nothing filled in, it doesn't actually submit. Great, we've prevented the users from submitting invalid data. However, the user isn't given any indication of what's wrong. We'll fix that in the next lesson. In this lesson, we need to display an error message when a field fails validation. Let's pull in another VeeValidate component that will help us out here, the error message component. I'll also prefix it with V, even though it already consists of 2 words. That way, it's more apparent that it's coming from the VeeValidate library. Now, we can use the component to display the error message for the name field. I'll do so right under the name field. Notice here that we had to set the name attribute on the error message component to the same name we provided on the field. So, if we wanted to show the error message for the username, we need to set the name prop to username. Lastly, I'll add a class that's styled in our main style sheet to each of the error messages, just to make them look a little nicer. In the browser, before I do anything, the error messages are not displayed. But if I attempt to submit the form, they appear. Awesome. Also, after I do provide a valid value and blur the field, the error disappears. I mentioned previously that there are 2 ways to provide the validation rules to VeeValidate. So far, we've provided them at the form level. Let's look at the other option now, that is, providing rules at the field level. First, I'll copy the function that makes a field required. Then, I'll remove the validation schema altogether. And, on the name field, provide a rules prop where I'll paste in the function. If we check things out in the browser, you'll see the validation on the name field works just like it did before. However, we've now lost the validation on username. To fix this, we can turn the required function into a method. And call it for both fields. Great, this works. So far, we've manually defined our rules at the component level. But what a pain this would be if we wanted to use the same rules across multiple forms. Plus, why even write our own rules in the first place? Form validation is a very common thing, and a lot of rules are very common amongst all applications, including the rule required. Let's address both of those issues in this lesson. I'll start by creating a plugin for VeeValidate. And, of course, this means we'll also need to register the plugin in main.js. Now, back in the plugin, we can import a function from VeeValidate called defineRule. This function allows us to define rules globally for VeeValidate, rules that can be used anywhere throughout our application. The first argument is the name for the rule. The second argument is the function like we had before, so I'll just copy and paste the required method from the register page. Now, we can delete the required method from register.view. And where we were using it as a rule on the name field, we can now reference the globally defined rule by its name. I'll do that by removing the colon from the prop. Now, the value of rules evaluates as a string. Let's do the same thing for username. Now, if we check things out in the browser and attempt to submit the form, sure enough, we get the same validation errors as before. But now our required rule is available across our whole application. To prove it to you, let's add validation to the login form. I'll change out form to vForm, remove .prevent, replace the email and password inputs with vFields. I'll also add the names to the vFields. And make them both required. Notice, we didn't have to create any kind of required rule here in the sign-in page. Instead, we're referencing the globally defined rule. Let's also provide the error messages for each. Lastly, we need access to the field, form, and error message components. We could import them directly into the sign-in page component, just like we did before. But since we'll be using them throughout the application, let's go ahead and use our new plugin to register them globally. So, in VeeValidate plugin.js, first we'll import them. Then, use the component method on the app to register them. Cool. That also means we can remove the manual import over in register.vue. All right, let's visit the sign-in page and see if the validation is working. When I attempt to submit the form, yeah, our validation is working here too. Great. So now we can reuse rules across our whole application. But it still kind of stinks that we need to manually define rules that are commonplace. We can fix that too, though. Let's install a collection of predefined rules provided by VeeValidate. The package is called at VeeValidate/rules. Now, we can import a predefined required rule from the new package. And replace our manual implementation with the new rule. If we try things out in the browser now, you can see that we still get our validation working just as it did before. Required isn't the only predefined rule provided by VeeValidate. In fact, looking at the docs, we can see a number of other useful rules, including min, URL, email, and a whole lot more. In many cases, one particular form field will need to support multiple validation rules. For instance, the email field should be both required and a valid email. How can we assign multiple rules to a single field with VeeValidate? First, let's globally define an email rule. We can use the predefined one from the VeeValidate rules package. Now, on the registration form, let's make the email field both required and a valid email. We have two options on how to do this. We can either provide an object where the keys are rules, like this. Or we can accomplish the same thing using a string and separating the rules with a pipe. Lastly, we'll insert the error message. If we check this out in the browser, you can see the email field is invalid when it's blank. Not only that though, if we provide an invalid email address, it's still invalid. It's only after we provide a valid email address and blur the field that the error goes away. Some rules need to be able to take in arguments, such as a min rule or a max rule. Let's see this in action by requiring our password field to be a minimum of 8 characters long. First, we'll import the predefined min rule, and then use it with the fine rule. Now, let's use the min rule to validate the password field on the registration form. First, I'll make the field required. Then, I'll use the pipe to also use the min rule. But, how do we inform the min rule what the minimum length should be? Once again, we have two options. If we're using the string format for our rules, like we're doing here, we can separate the argument from the rule with a colon. On the other hand, if we were using the object syntax for the rule, we could provide the argument as the value of the object's property. But I prefer the string syntax, so we'll just revert that. Lastly, I'll provide the error message for the password field. In the browser, we can attempt to submit the form. When we do, we get the error message on the password field. Now, I'll provide a password that's too short, and after blurring the field, the error message remains. But if I make the password longer and blur the field again, the error message disappears. You may have noticed that since defining the rules globally, we're given the same error message no matter what rule failed. For instance, on the password field, the error for an empty password is password is not valid. Then, when I provide a password that is not long enough, the error message is still password is not valid. Wouldn't it be nicer if we could tailor the error message to the rule that it failed? In other words, when the password is empty, it should say password is required. And when the password isn't long enough, it should say something like password must be at least 8 characters long. Let's do that. This can be accomplished with VeeValidate's i18n package. Let's start by installing it with npm. I'll type npm install at VeeValidate/i18n. As hinted at from its name, we could also use this package to provide internationalization for our error messages. But we can also just specify a single language to customize them. We'll do that in this video, as internationalization is beyond the scope of this course. Next, we need to import the configure function from VeeValidate, along with the localize function from the i18n package. Then, we can call the configure function and pass it the generate message option. Here, we'll call localize, passing the language as the first argument. and an object with a messages property as the second argument. Now, under messages, we can map rules to messages. For instance, required will say, this field is required. Now, when we check out the password field, a blank input gives the message, this field is required. But if I type in a few characters and then blur the field, the message changes to, password is invalid. Nice. Let's customize the message even more. Instead of saying, this field is required, it would be better to say that password is required. We can use a placeholder like this to instruct VeeValidate to replace the placeholder with the field name. Sweet. We can do one last thing to make our message even better. You'll notice the word password here is lowercase. That's because this is the actual name of our field. Oftentimes, the name of our field, though, is not so pretty, and the label on the field would be better to display in the error message. We can support this by passing in a label prop to the V field. Yeah, I like that better. Now, let's provide messages for the rest of our rules. Email is pretty straightforward. Field must be a valid email. Min is a little bit more complicated though. It takes in an argument. How can we say the field must be some variable number of characters long? Well, just like there's a placeholder for field, there's also a placeholder for arguments. The 0 here targets the first argument passed to the rule, while the min in the curly braces supports passing the arguments as an object instead of an array. Let's see how that looks. I'll type a password with not enough characters and blur the field. Perfect. Sometimes, you might need more information from your backend to be able to completely validate a field. That's the case for the username and the email on our registration form. Really, we should validate that they are not already in use. Thankfully, VeeValidate supports async validations out of the box. Let's create a global validation rule called unique. And we'll make it async so that we can wait for some data from the Firestore. Let's start out writing this rule as if it were exclusively for username, and then we'll extend it with some arguments in a moment to make it more flexible. So, to check if the username is already in use, we want to look in the users collection for a document where the username is equal to the value of the input. And we can use the get method to fetch it only once. Let's go ahead and import Firebase as well. Then, we'll assign the result to a variable called querySnapshot. On querySnapshot is a property called empty that tells us whether a document with the specified username exists or not. We'll just return that because empty being true means that the username isn't already in use, and returning true from a validator means that it passes validation. Lastly, let's define a message for the unique rule. Now, over in the registration form, we can use our new rule and just on the username field for now. Great, let's see how that looks. When I type in any username and blur the field, the required error disappears. But if I provide the username that I've already registered with and blur the field, we get our new error message telling us exactly what's wrong. Great, this is perfect. Let's make the unique rule more flexible now. That way we can also use it on the email field or in the future any other field we'd like to use it on. Looking at our rule, the two things that could be variable are the collection that's being searched through and the field name. Let's turn those into rule arguments. We can access the rule arguments via the second parameter on our validator function. Then, we'll use array destructuring to get the collection and the field. Then, we can use those in the Firestore query. Remember, it's also possible for the arguments to come through as an object, depending on how they're defined on the field. So, let's support that too. First, we'll initialize collection and field so that either the args object or the args array can set them. Then, we can check if args is an array, and only then do our array destructuring. Otherwise, we'll destructure the variables from the object. Notice that we've got a red squiggly line under the equals sign. When we are destructuring an object into variables that already exist, that is, the line doesn't start with const or let, we need to wrap the whole thing in parentheses so that the JavaScript engine doesn't confuse our object literal with a code block. With that, we need to provide the parameters on the username field in the registration form. However, now we can also use the same rule on the email field. And actually, just to be sure that the object syntax for the arguments works, let's do that on email. Alright, let's check it out in the browser. Providing my username still causes the error. And now, filling out the email field with my existing user's email also throws the error. Perfect. Once again, I'll take the rules back to the string syntax, as that's just my preference. At this point, we've got a lot of duplicated code for each field. Every one has a form group wrapper, a label, a v field, and an error message. And they share some repeated attributes throughout them, such as the field name and the label. Let's bundle up all these elements into a component that we'll call AppFormField. I'll create the file paste in the markup, and just reformat it a bit. Now, we can take in the field name and the label as props. Then, we can use the same name for both the field and the error message, as well as the for attribute on the label and the ID on the field. Next, let's use the label prop to fill in both the actual field label and the label prop that we passed down to the VeeValidate field. Now, let's think about the other attributes here for just a second. The field type and the rules, well, they shouldn't be hard-coded. We don't want every field to be of the same type or have the same rules. Instead, let's make those dynamic by binding all the component attributes to the field. This way, each instance of AppFormField can provide not only its own rules and type, but also any other typical form input attribute, such as placeholder or disabled. On the other hand, the class attributes on the field and the error message are perfect as they provide consistent styling for our fields. Now, there's one last thing we need to deal with. That is the V model. Let's make it so that we can use the V model on our component, just like we used V model on the V field. To do that, first we need to take in a model value prop. Then we'll provide that model value as the model value on the V field. Lastly, we'll listen to the input event on the V field and emit a model update event with the value of $event. Alright, I think our component is ready for prime time. Let's use it to power all the form fields now on the registration form. First, I'll replace all this markup for the form field with our component. And on the component, we'll provide the V model, the name, the label, and the rules. I must say, I think that looks a lot nicer than what it was before. Now, I can do the same for the other fields. For username, for email, and for the password. Lastly, avatar is a bit more complicated, so let's just leave that one as is for now. Alright, let's see how things are looking in the browser. Great, things are still working, and all the field error messages include the pretty label instead of the field name. We hadn't done that for them previously, but now it's baked right into our component. On top of that, we've also dried up our code and made things a lot more readable. Awesome. As of now, our AppFormField component can only handle input fields and not other kinds of fields like selects. But we haven't had a use case for selects yet, so let's not cross that bridge until we have to. It is important when building real-world applications to have forethought and build scalable code. However, it's also important to not over engineer things and waste time writing code that will never even be used. Now that we've got the app form field, it's fairly straightforward to add validation to all the forms. Let's update the login form to use the new app form field. We already started implementing VeeValidate here, so we just need to implement the app form field now. First, I'll remove the bulky markup here and replace it with our handy component. I'll do it for email and then for password. Over in the browser, we can visit the sign-in page, hit login, and yeah, our validation is still working. Let's log in to see what other forms we should add validation to. Alright, let's tackle the Start a Thread form. We'll open up the thread editor.vue file, which powers both thread create and thread edit pages. I'll start here by changing form to vform and removing .prevent. Now, the first input will be simple. It's just a normal text input. And we can make the field required. The second is a little bit more difficult because it's a text area and our app form field is only set up thus far to handle regular inputs. So, how do we handle this? Well, the field component from VeeValidate actually takes an as property where we can specify what kind of field we want. So, because we've bound the adders to the v field, then we can use the as attribute on our component as well. That vbind adders will also allow us to pass in the rows and calls here. That should do it. Over in the browser, I'll try to submit an empty form, and sure enough, we get the validation errors. Then, after filling out the form with the valid information, it submits as it should. Great. Now, let's try to edit the thread. I'd expect that this will work too, since the form edit page shares the same form that we just added validation to. If I clear out the title, sure enough, we get our validation error. Now, we can quickly do the same for the post editor component. We'll change form to vform and remove .prevent. Then, we'll use the app form field. I'll leave off the label here, as it just doesn't look right in the layout and wasn't on the original form. Now, in the browser, when I try to submit an empty post, the validation catches it. You'll notice, because we didn't pass the label, the error message component falls back to the field name. But I think that actually works out pretty decent here. After I fix the text and submit, the post is added to the thread. However, the validation error message shows up again. That's because we're resetting the text to an empty string, and that's confusing VeeValidate. Let's force the vform component to re-render so that it doesn't think that it's already been focused once before. We can force the form component to re-render by giving it a key attribute, which we can initiate to some random thing. And then, after form submit, set it to something else. Now, when we do the same thing as we did before, the error message is gone after submit. It was admittedly a bit of a hack, but every once in a while you'll find that you have to do kind of hacky things like this. Alright, this should also work for editing a post, since it also uses the post editor component. And yeah, that works too. Alright, I think the last form without validation is the profile edit form. I'll knock that one out behind the scenes and let you code it up for your application on your own. It'll be some good practice and will really help it stick. I'll warn you though, it does have a trick to it for the username in the email field when using the unique rule on it that will require a slight modification to the rule itself. But I have faith in you. If you need any help, feel free to take a look at the source code for this lesson, as the complete solution can be found there. The location input on the user profile form is a little wide open and vague. Let's give the users some country options to choose from. We can accomplish that using the free REST API, restcountries.com, combined with a native browser solution for creating autocomplete dropdowns. Let's start by getting the data from the API. I'll create a method in the user profile card editor called load location options. And it should be async, as we'll need to wait for the response from the API. Then, we'll use the fetch function to make a request to the API endpoint that returns all the world's countries. Finally, we'll store the results in a local data prop. This, of course, means we'll need to define the location options data. And I'll initialize it to an empty array. For now, let's call this function in the created hook, fetching the countries as soon as the component is created. Now, if we take a look in the DevTools, we can see what was returned from the API. We've got an array of countries, and each individual country has a number of interesting properties, like some country codes, a flag, and a name. What I want to do is use the common name of each country to make up the options. Cool. So now we just need a way to show the options to the user as they type into the location's input. To do that, we can provide a data list under the location's input. Give it the ID locations, and use v4 to loop over all the location options. I'll use the location's common name for the option value. And use the same for the key. Lastly, I'll remove the closing option tag, as it's optional. Now, in order to link the location text input with the data list, we need to provide the list attribute to the input. It should match the ID on the data list. With that, we should have things working. Sweet. Typing a country name in the input provides the user with some options to choose from. And they still have the option to provide their own thing if they'd like. That's so great. It's worth clarifying that this is not a feature of VeeValidate. The data list element, as well as linking it to the text input with the list attribute, is a native feature of the web browser, and you can use it anytime you'd like. Let's do one last thing to improve our location's input. Right now, the request to get the location options is being made whether the user intends to use them or not. You can see how the request is being made on page load in the Network tab. Let's only load them in once we know the user is likely to use them. We can do that by listening for the mouse enter event on the input, and only load in the locations once the user has put their mouse over the location's input. Also, so that we don't reload all the locations every time the user hovers over the location's input, let's modify the load location options function to return early if the load options already exist. Lastly, we can remove the created hook. Now, in the browser, if we reload the page, you can see that on page load, the request doesn't exist. If I go to set my location, the request is made, but it's being made twice. What's going on here? The issue is that in AppFormField.Vue, the event listener is being added to both the V field and the form group because it's the root element. In order to prevent this, we need to set the inherit adders option to false. That way, the event listener and any other attribute provided to the component will not be added to the root element. Instead, we'll let that vbind adders handle everything and bind all the attributes and event listeners to the V field. Now, if I go to set my location in the browser, the request is made only once, and the options appear just in time for us to use them. In conclusion, we could actually query the API directly as the user types, passing the API the input's value and then only getting back the relative results. However, I chose not to do that as the payload for all the countries really isn't that large and didn't cause any performance issues just loading them all in. Most importantly, this allowed us to let the browser native data list do the filtering for us without any extra work on our part. This approach won't always be the correct solution, but for smaller payloads that are guaranteed not to grow, like our countries, it can work well.